Hello, my name is Maximilian Ruszkowski, and today I will be presenting my robotic arm video. So let's begin by introducing the challenge. The challenge aims to replicate the process of robotic surgery, and during the challenge we had to use the robot we created to lift, move, and deposit magnetic blocks into designated points along the travel envelope. So this is the travel envelope, there's a minimum point and there's a maximum point, and we had to satisfy all the possible points along this travel envelope to be successful during the challenge. So our robot relies mostly on horizontal motion and only uses vertical motion when picking up the metal block with the magnet. This video kind of illustrates that. So this is a video from the challenge, and as you can see, our robot mostly uses vertical motion when using the magnet, but all the other times it's only using horizontal motion, shown by the servo. This was really effective as it allowed us to place joint first in the competition. So if we are talking about CAD, so if we're talking about CAD, we use Fusion 360 in combination with 3D printing and laser cutting. And the original base that was provided, which is this base here, this is the representative CAD file for it. This base only allowed for vertical motion, but we wanted to alter it to allow for the movement of the robot to be horizontal. So we did this by taking this base and rotating it 90 degrees to get our first iteration of the new base. And here it is. So this new base was made from acrylic and was used in laser cutting. So laser cutting was used to make it. And we later took this same idea, but we adapted it to be 3D printable and to be made from plastic, which made it more rigid and more stable. And this is the CAD file showing the most recent base. In terms of prototyping, we encountered two main issues. So issue number one was that there was a weak spot in the elbow joints of the robot, and we addressed this by laser cutting a white acrylic plate to stabilize the joint, shown here. And the second issue was that there was some instability from our acrylic base plate because acrylic itself is not a very stable material. So we addressed this by actually creating a 3D printable version, which is made from plastic, was thicker and was more stable, which fixed the stability and rigidity issue. In terms of software, the code we use implements two main functions. Function one is the individual movement of all three servos, and function two is the operation of the magnet. Here, this clip is showing the two functions. So the magnet is turned on and off to pick up the block, and the second function is the movement of these servos. There was 3 servos in total. All the code can be found on GitHub here with comments to describe all the specific functions of the code, but I would like to draw our attention to one specific advantage of our code, which was that we decided to print the button state onto the terminal, so we always knew whether the magnet was on or off during the competition, and this helped remove the possibility of confusion. So in conclusion, most of our advantages came from the fact that we focused on horizontal motion. So these advantages included a max reach of about 450 millimeters, a good range of motion, a stability and weight distribution. But at the same time, there were some blind spots due to the limited range of motions of the servos in certain positions, and there was some unreliability with the magnet as there was a time delay from the button being pressed and the magnet being turned on. In terms of modifications, I think we could have used the magnet with less time delay, servos with a greater range of motion, and also have the ability to later cut different lengths of metal plates, these blue metal plates here. I think that is everything from me. Thank you very much for listening.